So I was doing some research for an upcoming project and I had a bit of a moment. I seem to have accidentally built a mechanical keyboard. Doing research is really cool because it allows me to see how other people have approached a particular problem. However, for me, it does pose some dangers. While browsing Google or tech sites or how-to sites, I often see little projects that are like shiny little distractions. And before I know it, I'm 3/4 away into planning a new project that I never intended to do in the first place. Is anyone else like that? Or is it just me? Working in IT as my day job, I use a keyboard a lot. And one of the things I was looking for was an ergonomic keyboard, just to reduce the amount of strain that I'm putting on my fingers, my wrists, and just try to improve my comfort factor while doing my work. In the process of researching where I was going to buy a keyboard, this little voice in the back of my head said,
"Hey Steve, you're a maker. Why not make a keyboard?"
and the logic part of my brain said,
Yeah, that sounds like a really cool idea.
So that led me on to a bit of a journey where I stumbled across a unique looking keyboard, the Redox hand-wired keyboard. It doesn't require a PCB or a circuit board to make the keyboard. It's just a case of an enclosure, some microcontrollers, some switches, some diodes, and some wire. And quite a bit of patience. Yeah, quite a bit of patience. After printing out the enclosure, it's time to insert the switches into the top plate, making sure they're rotated in the correct orientation. Next up, it's time to get the diodes installed. But before we go there, let's talk about how a keyboard works. A keyboard works by using a series of columns and rows to detect a key press. The diodes are in the circuit to prevent feedback from one column to another row accidentally, to ensure that there are no ghost key presses. Without the diodes, pressing multiple keys at the same time can cause unusual behavior. With the diodes, the keyboard can have multiple key presses and execute them normally. Using a pair of tweezers, I bend a loop in one leg of the diode, making sure the black line is on the bottom, facing away from the key switch. This is really important that the diodes are installed in the correct orientation, otherwise the key presses won't get recognized at all. As we'll come to later, the diode leg is then soldered to the diode next to it in the next column, saving on the amount of wire used. And using a pair of tweezers, I carefully align and orientate the leg of the diode, trying to make this look as neat as possible. Now the rows are complete, it's time to construct the columns. Here I'm using some magnet wire or enameled wire. Enameled wire is essentially a very thin copper wire with an enamel coating. The enameled wire is insulated and will only conduct where we solder it to the switch. Next up, it's time to prepare the microcontroller. And essentially what I'm doing here is I'm tinning the pads of the microcontroller that I'm going to be using. Using the build log, you can see the pins that you need to use for the columns, the rows, and the communications between each half of the keyboard. This is going to use a TRRS cable and a TRRS socket to transfer power and the data via I2C across to the second half of the keyboard. Now, it's really important that you match up the correct pins with the microcontroller. The pinout of your microcontroller may differ to the ones documented, as it did for me. So always look at the schematic and identify the correct pins before making permanent connections. Next up, I superglue a case of the microcontroller inside the enclosure of the keyboard. And this is just to secure the microcontroller inside of the keyboard, rather than having it flapping loose or having double-sided tape holding it on top of the faceplate. First up, it's a case of connecting the row wires to the corresponding row pins on the microcontroller. And then the task of soldering the wires from the columns to the corresponding column pins. As I go, I am testing to make sure that things are connecting and working properly. And then next up, installing the button that I'm going to use for resetting. The reset button is used to put the microcontroller into programming mode. So having a button on the outside of the case is really handy to be able to put this into programming mode relatively easily without having to open the enclosure each time you want to program a firmware. Then I connect power, ground, serial clock and serial data to the TRR socket, making note of which pins are used for which signal. It's important that we keep this the same, both sides of the keyboard, to make sure ground goes to ground, 5 volts to 5 volts, serial clock to serial clock, and serial data to serial data. Otherwise, the second half of the keyboard won't power up and data communications will fail, and only half the keyboard will work. With the first half of the keyboard now completed, it's time to repeat the process with the other half. Initially, I used the QMK configurator to compile the first firmware and install onto the device using the QMK toolkit. But then a friend of mine put me in contact with another content creator called Cujo on Twitch. And he builds mechanical keyboards and has a real passion for them, unlike me, who is dipping his toe into this world for the first time. He walked me through the process of installing a fork of the QMK firmware, which meant that if I wanted to remap the keyboard, I could do this on the fly using the VILE configurator, as opposed to having to flash the firmware each time I wanted to update things. If you want to check out Cujo's Twitch channel, see the link below in the description. Now, while testing the keyboard, I found a couple of problems. I mentioned earlier in the video that the diode has to be installed in a particular way, and I'd actually overlooked one of the diodes and installed it in reverse, meaning that one of the key presses didn't work at all. This was a simple fix, but I did have to strip the keyboard down, uninstall the diode, cut a new one, and put it back in place, at which point everything was working fine. I love this keyboard, I love its look. The challenge for me now is, how do I use it properly? I'm now gonna have to learn how to touch type. Oh, and those keycaps.
Squirrel!